Chemical bonding. Almost everything we see or touch in our daily life is the result of a chemical bond. The air we breathe, the food we eat, the clothes we wear, and so on, are all made up of one or more chemical bonds. The world is generally not composed of isolated atoms. Rather, it is composed of molecules formed as a result of chemical bonds. The strong force that holds together the constituent particles, atoms, ions, or molecules in a chemical species is known as chemical bond. The chemical bonds are broadly classified as ionic bond, and covalent bond. Let us discuss these chemical bonds in detail in this module. The bonding which results due to the complete transfer of valence electrons between atoms is called ionic bonding. It is a type of chemical bond that generates two oppositely charged ions. Ionic bonding is observed because metals have few electrons in its outermost orbital. By losing those electrons, these metals can achieve noble gas configuration and satisfy the octet rule. Similarly, non-metals that have close to 8 electrons in its valence shell tend to readily accept electrons to achieve its noble gas configuration. In ionic bonding, more than one electron can be donated or received to satisfy the octet rule. Sodium metal has electronic configuration as 2, 8 and 1. It has one electron more than a stable noble gas structure. If it gives away that electron, it would become more stable. On the other side, chlorine has electronic configuration as 2, 8 and 7. It has one electron short of a stable noble gas structure. If it could gain an electron, it too would become more stable. Thus, the sodium atom donates its valence electron to achieve stable octet configuration. This creates a positively charged cation due to the loss of electron. The chlorine atom receives one electron to achieve its stable octet configuration. This creates a negatively charged anion due to the addition of one electron. The sodium ions and chloride ions are held together by the strong electronic attractions between the positive and negative charges. Covalent bonding. A covalent chemical bond results from the sharing of electrons between two atoms with similar electronegativities. The electronic configuration of chlorine atom is one electron short of the argon configuration. The formation of the chlorine molecule can be understood in terms of the sharing of a pair of electrons between the two chlorine atoms, each chlorine atom contributing one electron to the shared pair. In the process, both chlorine atoms attain the outer shell octet of the nearest noble gas, that is argon. The dots represent electrons. Such structures are referred to as Lewis dot structures. Thus, the chlorine atoms are joined by a single covalent bond. A single covalent bond is formed when one pair of electrons are shared between two atoms. It is depicted by a single line between the two atoms. A double bond is formed when two atoms share two pairs of electrons with each other. It is depicted by two horizontal lines between two atoms in a molecule. This type of bond is much stronger than a single bond, but less stable. This is due to its greater amount of reactivity compared to a single bond. For example, In the carbon dioxide molecule, we have two double bonds between the carbon and oxygen atoms. When three pairs of electrons are shared between two atoms in a molecule, a triple bond is formed. It is the least stable out of the three general types of covalent bonds. The two carbon atoms in the ethyne molecule are joined by a triple bond.